Hi guys! Today we'll be having yet another conversation about kinematic equations. Time for the classic case.
Oh, Daphna, the classic cliff problem.
Hope everyone's ready to jump right in. Don't jump off.
Let's start off with the basics. Let's talk about acceleration.
What is there to know? Isn't acceleration the same?
Almost all the same. You just need to know which direction is positive and which direction is negative. In our case, we're going to keep positive up and negative down.
Oh, makes sense.
Do you remember the acceleration rate due to gravity?
Yes! It's typically 9.8 meters per second squared, but let's round it to 10 for our sake.
Great call, Daphna. Keeps things easier. Okay.
All right. Now can we move on to the actual problem?
Daphna, what kind of problem? Guy trouble? School trouble?
No, Alan, the actual math problem.
Oh, yeah! Here, why don't we draw it out first?
How about I'll draw, because we clearly know who has the better handwriting
Okay,
here.
sounds good.
All right. Alan, why don't you read me the
Yeah, I'll
problem?
just read it. I'll read it quickly. Tom Brady is standing on the top of Gillette Stadium and throws the ball straight up at 45 meters per second. The peak of Gillette Stadium is 490 meters above the field.
So now for my drawing. So here's Tom Brady and his little football, and we're just going to draw it in action.
Right.
490 meters, you know, everything's in meters. And we're going to just divide it up into two parts. Let's calculate Tom's throw until its highest point. This will be the end of part one.
Okay. So Daphne, we know that the velocity at its zenith, Dr. Marquardt, you like that, is 0 meters per second. Doesn't that make our final velocity 0?
It does. It does. Oh, whoops, I drew it in the wrong place. Ignore me. That was silly. Didn't have my bean soup last night.
We're testing.
We're just testing you. Okay. All right. Now we have to find the distance and time for our first part of the problem, because we know our initial velocity, as stated in the problem, was 45 meters per second.
Right.
And we know acceleration due to gravity is 10.
And Daphne, why is it positive 10?
Because we defined up as positive.
Ooh.
And because the ball is originally going up and then dropping down, we know that it's positive 10 meters per second.
That's awesome.
So let's solve for time and distance.
Okay. What equation should we use?
Let's use, hold on, smartboard probs, hold on. Okay, let's use equation 5 and solve for distance. So we all know that equation 5 looks like this.
So
If you plug it in.
Final velocity equals square root of VI squared plus 2AD. So we plugged all of our numbers in. We have 45 as our VI, and then we've got 10 as our acceleration. We're trying to find distance. And our final velocity is 0. And the answer is...
Dun, dun, dun.
101.25 meters!
Yay! What a far throw for Tom Brady.
Yeah.
Unlike the real world.
He's got quite the arm, Daphna.
Yeah, clearly. Alright, so now we just solved for distance. Yay. Now let's solve for time.
Okay, Daphna, what equation do you think we should use? Oh.
Equation 1! How
Yay!
convenient! Alright, changing distance equals half of the average velocities times time. So we just found out distance was 101.25 meters equals 1.5. The average of the two velocities is just 45.
Okay.
Because, you know,
Uh-huh.
times t. So when you do all that math, you should get time is 4.5 seconds.
4.5,
Long
yeah.
distance in such a short time. I know, it's shocking. So
Wait.
now we have distance and time.
So now can we move on to part 2?
Yes!
Yes!
Let's do it.
Awesome.
Alright, so now we got part 1. Where does part 2 pick up?
Right about there.
Yeah, that's good.
Uh-huh.
Alright. What would you say the height of the ball is at its highest point?
What is the height of the ball at its highest point?
In addition, so what do you have to do? We just found out the distance for this part, correct? But now we need to count the 490. So for our distance, we're going to take our 101.25 meters from the first part, plus the 490 given, to get our total as 591.25 meters.
Daphna, that was quick math.
Yeah. And you know what? We just talked about acceleration. Do you remember what acceleration is?
Yeah, it's negative 10.
Why is it negative, Alan?
Because it's going down.
Oh, it's going down for real?
It's going down for real.
Okay, so now, how do we know that VI is 0?
Because the ball's not moving when we're starting.
It's at the highest point.
It's the
0.
zenith.
Ah, the zenith. So now what do we need to find?
Daphna, I think we should find the time.
And?
Final velocity.
Alright, so first let's solve for final velocity.
Yeah, good call.
Equation 5 again,
Classic.
you know. It's a good one.
Equation 5.
It's a great one. So we plugged in all our numbers.
Mhm.
We got that our final velocity should be 108.74 meters.
You are so
per
fast
second.
at this.
You know what? A lot of practice, a lot of
Yeah.
years teaching physics. It's
Right.
taught me well.
A lot of experience.
All right. Now, I plugged that in. Now, what else do we still need to solve
Daphna,
for?
let's figure out the time.
All right.
I think the next slide has that equation.
It does.
Let's check that out.
All
Okay.
right.
So we use equation 2 for this, where we have final velocity equals initial velocity plus acceleration times time. So we already know our final velocity is negative 108.74, and that,
Don't forget the negative. It'll mess you up.
good call. And then the VI is 0, and then the acceleration is negative 10, and then we're solving for t. And when you do this, time equals 10.874
seconds. Don't
seconds.
forget
Good
to
call.
label. That was silly. Uh-oh, it's a different...
You almost got it, Daphna.
I know. So now we have all 5 factors for both parts. So
Yay.
basically, you can solve whatever you want. How long it took for the ball, how long the distance is. You
Right.
can solve for anything. So you want to give us some example problems, Al?
I think we can stop here.
All right. We're gonna
Awesome. Thank you for watching and listening. Have a great day.
Tips are more than welcome.
Yeah.
We can cut off though.